right, good evening. No, good afternoon. Not good evening. Okay, guys, we're going to have a quick look at the DigiKeys accessory decoder. So we've got that, and we're having lots of questions about how to program it to do different things. So we thought we'd have a quick look. So here we've got set up a few different devices. As you can see, I've got DigiKeys DR4000, so that's over there. I've got it set up in Z21 mode. I've got a LocoNet throttle here connected up to it as well via LocoNet. And then we've got the 4018. So here you can see the 4018. And I'm just trying to move it a bit. I've connected into it just some LEDs on the outputs and a light on this output, just so you can see how making different changes to it will affect how it would drive different devices. I've then got this cable that goes into power and signal, so it's looped in and then it goes on, and I'm programming on the main. So if we were to look at the DR5000, it actually goes into the main line power here. Okay, so you can see that. Okay, so there's a load of other stuff. So at the moment, the 4018 is in default mode. So if you would take this out of the box, they set it up to drive solenoid snap point motors. Now, there's also loads of people talking about, will it drive seeps and will it drive this, that and the other? I'm going to tell you no, because if you look at the specs of the 4018, it states that it has a 2 amp output per channel, but at any one time only 3 amps. So if you try to drive more than one seep at a time, which sometimes happens when you route setting or something like that, it won't. It was designed in the first instance for this type of point motor, made by Fleischmann. This one is. Roco do a similar one, Pico do a similar one. These only take maximum 500 milliamps to drive them, so they don't need the high amps like our Pico point motors or our seeps from Gauge Master. They need a lot more power. So the 4018 isn't really designed to drive those devices. So, but out of the box, the 4018 would drive that device. I haven't got it set like that at the moment, but we will. I will now put it into that mode. So if I'll try and show you this all at the same time. I'm going to use, just for now, the DigiKeys DR5000 configuration software, and I'll show you how you would do the programming. So hopefully you can see this. Okay, so I'm programming on the main. So in the DR5000, if I just close all these windows, you get the program track output up here. Open that up. Then you click on program on the main. Now, the way this accessory decoder works is you have to give it this long loco address. So it's 9999. Some digital systems, you cannot program on the main this address, this length of address. So it can be changed in the 4018 to a lower address to accommodate other systems so they can use this. But we'll talk about that another day. But for today, we're just going to talk about some basic things. So the 4018 has some set into it some defaults. And like we were saying, out of the box, that default is, I'll show you this. this solenoid type of point motor. So that's default preset 0. So I'm just going to put this into that mode because I haven't actually got it in at the moment. But the way you would do it is this. Let's just zoom out a bit. So the first thing you do is you press the program button. That puts the 4018, and you see all the lights went out, into programming mode. So it can accept any commands you send it now. So we're programming on the main. We're talking to the local address of 9999. CV47 sets the presets. So preset 0 is the default. So if I put that value of 47 to 0, and then I send that to program, it confirms it. We then turn off the program mode. You'll now notice that on the 4018, all the lights are still off. So that's fine. If I then turn one on, it then activates it ready for the next command. So if I send it, if I throw the address of 2, because this is an output 2, you'll see the light goes on and off, on and off. The reason it does that is because if it was a solenoid, it would be post activation. So it says, I'm on, I've thrown, I'm off. Throw it the other way, obviously does the same. So if you watch what happens when I click on address 2 here, so if I go green, the light comes on, and then I throw it the other way, red, the other light goes on. So that's a post mode. So that's for solenoid type of point motor. Now there's other presets on here we can have a look at. So preset 1 is for lights on and off. Now within this preset, it does multiple things. It just doesn't set one CV within the 4018. It sets multiple CVs. So how bright the output is if it was a light. That the light's an on-off function. Now if the light's an on-off function, these paired outputs as they are at the moment for the solenoid go to single outputs. So rather than have just 8, it now puts up to 16 individual outputs. So let's just do that. So press program mode on. We put in a value into CV47 of 1. We press go. Programs it. We turn the programming mode off. Now you see all the lights are on. Now, because they're now all on off, I can turn 1 on and 2 on. So now the addressing is every single output. You've got address 1, 2, 3, 4. So 3 and 4 turn this light on and off, on and off. Obviously all the other outputs, if I was to turn them all on, they slowly all come on as I turn them on. So now you can see that in this mode, it's got 16 individual driven outputs. Brilliant. If that's what you want this just to control lights in buildings and other things like that, that would enable you to do it. Okay. Now some people might on their layout have certain areas where they wish to have lights driven from signals, point motors. So this one accessory decoder in that specific area could drive, well, as we've got over here. So what I've got over here, I'll try and show you. So on this 4018 I've got here, it's driving lights, signals, point motors, different types, solenoid, MP1, MP5, MP6. It's also got the 2 aspect dipole servo signal here. Now, even though it's got 2 servos inside it for driving, it doesn't actually use a servo accessory decoder to drive those servos. So the 4018 is capable of driving it through their little relay unit because it's just switching from one current to the next. It's just basically like you switch an analog switch, a double throw switch. So that relay is just switching between the outputs, and it makes it either drop or raise the signal. So in this instance, you see I'm using it to drop this one 4018 to drive lots of different devices, whether it's a light in a house or a building, or even a signal with 2 aspects. So you can configure the 4018 to drive lots of different devices. So a customer has asked, and this is kind of what's prompted me to do this, he wishes to drive certain types of things. And what his request was to drive, excuse me, MP1s or 5s, it's the same, but he wanted to have, let me just check my list here, 1, 2, 3, 4, 5 MP5s, and then the rest of the outputs that's left, so from 11 to 16, just to be in on-off switches. So as we got it in this mode, like this, he wants the last one's that, but the first outputs, he wants to be for the point motors. And the point motors he's talking about, I can show you those again, is over here. And it's either the MP1s or the 5s. The way they're driven is the same, but this customer has the MP5 version. So there's a few CVs you have to change. Now, DigiKeys obviously have got the manual on their website, which you can download as a PDF format. So here it is on their website. It's quite in depth, and it shows you all the different ways to connect and describes everything in here. But there's some function mapping we have to do. It's not just a set preset, but the easiest way to do it is to define the more complicated use the preset as the complicated bit, and the more simple items to just change the CVs you want to do to how you drive those devices. So I will show you this. So this page shows you how to connect up for programming, and we're using this middle one, programming on the main. I find that the easiest way to do it myself. This shows you the presets. This picture here doesn't show you that this is a preset with all this. This is just showing you all the different ones that you could have. There isn't a preset that sets this one to do this one to do this as a whole. You have to define those yourself. So when you use a preset, it's all of those or all of those, okay? People have been a bit confused by that. Signals, this will drive also UK signals, not just European signals. We've got some very specific wiring diagrams for 2-aspect, 3-aspect with feathers. So if you are interested in UK signalling and you would like to use the 4018 to do that, we can send you that information. The other thing is we've got to be very careful of with the UK signalling is, if we look here, there's a little board in here. Now this board converts the 4018 from positive return to negative return. Now most UK signals are negative return, light signals are negative return wired, so you would have to use this adapter board. So this is the part number here, DR4103. That is the part number you would need to convert those outputs to drive what you want, okay? Right, so here we go. So this tells you about the presets, fairly straightforward. For CV47, and then just put in the value of one of these values to get the preset, which we've just shown you. But when you want to now configure each individual output, there's multiple CVs you have to change, especially if you want to have some for doing point motors, so 2 outputs switch on one address, or if then you want other outputs to switch so that paired output then becomes individual outputs and those addresses then are individual. You can do this. So the first thing we look at here in the manual, this describes how you can configure the output to drive different things, or how you can use a combination of this. So you could use, for example, this is for CV 113 output 1. It's broken down into different segments, so different bits. And one of the bits for the first output is the light intensity. Okay, now if you had a signal, you may wish to have the light on, and then as it changes states, it fades out. So you would have the intensity here. So this value here is the intensity. So 0 would be off, completely off. 15 would be maximum intensity, maximum power it puts out the output. Fade in and out. This is the amount of time it takes to fade. Now this is also linked to an earlier CV. So if you wanted this function on, you would add 1 to 15. So full brightness, add 1, which equals 16, and then how fast it fades is done here. You can see in CV111. And that's up here further up. So what value you put in here defines the amount of time in which it takes to fade that function out. So if you start to look at it, it starts to make more sense. And for each individual output, all 16 outputs, this table represents what you do in each of those outputs. So we know this customer wants from output 11 to 16, okay, to be on-off switches. So those CVs we have to change, along with some more CVs to function map the outputs, so each individual output is an addressed switched on and off, not the pair. So because he wants to start at 11, 11 is normally paired with 12, we got to separate that pairing and then turn those on and off. So I created, with help of a colleague of mine, this table. So this defines what we want to do. So if we look here, DR4018 preset 6, 8 turnout motors. So it puts the whole board, the first thing we do is put the whole board into the mode to switch these point motors. So that's the first job. So when we do that, we go CV47 to a value of 6. So that writes, so we'll do that first. So let's go down here. So put it into program mode. CV47 to a value of 6, and we program that. It receives it, we can turn program mode off. Okay, so now if we just look at this a minute, if I turn all of the outputs off, you'll see they all stay on, the lights, because it's continuous power to drive this type of point motor or a tortoise or something like that. So the light stays on because continually putting power out. So when I switch the address, if we look at this output here, there we go. So now address 8, because there's 8 outputs, not 16 at the moment. It's switching those two on and off, okay? And they stay on because it's constant power to drive this type of point motor. Hope that makes sense. But that's not all we want. The next step is to make the rest of the outputs from 11 to 16 individual on-off switches. So the first one's to stay as we've got them now. So preset 47 to 6. Now we need to individually look at these. So if we go back to here, so these are the MP5s, these first ones, the turnouts. Now we want to change it to switching. So rather than they be paired like this, so we've got 4, 4, 3, 3, 2, 2, 1, 1. Now we want to go address 11, 12, 13, 14, 15, 16. So we have to change these CVs, okay? So CV 123 to 128 to a value of 15. So we need to do that now. So put the programming mode on. Program on the main, CV 123 to a value of 15. Program that. 23 down 24, CV 124, the same. 125, the same. The same. 125, the same. 126. Same, 127 the same, 128 the same. So that's the first part. I'll just turn the program mode off a minute. Don't worry about any of the lights in the moment. The next thing we've got to do is function map the outputs here. So these few CVs we've got to change here, 172 through to 202. And we've got to change these values. So it makes the individual outputs individually addressed and switch on and off. We don't need to change these ones because this is to do with these point motors, the first 5, which you see down to point motor 5. The next ones we do, okay? So I'll just change these few CVs here, 4, 8, 16, 32, 64. They're the values of these CVs I've got to do here, okay? These ones should stay the same. And these ones I have to change here. So anything in yellow is the things I'm changing. So, CV 172 to a value of 4. Program mode on. Send that. 178 to a value of 8. Send that. 184 to a value of 16. And send you that. 190 to a value of 32. And send that. 196 to a value of 64. Send that. 202 to a value of 128. Send that. And now 3 more left. 175 to a value of 0. 181, value of 0. 187, 0 as well. Turn the program mode off. Okay, let's see if I've got it right. So the light goes on and off for the turnout. Output 5. So that's still turnout. And output 5 is still turnout, because let's see it's switching between the two. And the next ones should just all be on and off. So 5, if we put to the red state, so from the red light on, these are all individual. So we've got 6, 7, 8, 9, 10, 11. So that shows you that these last outputs are all on and off. So I can change any light on and off. And then the other LEDs from 5, output 5 down, they are on constant because they are the stall motors, which needs constant current to drive them. The light, again, this is just showing you, so it's switching between the two on one address, whereas the individual ones, I don't know if you can see what I'm doing. Let me show you. So you can see both things. So these outputs from 5 onwards, so address 7, 8, 9, 10, 11, are the last outputs on the board. So if I change their state, you can see that the lights come on. So that means we've now mapped this to drive 2 different types of device. That's what the customer wanted. This is the little table that we use, and we change it obviously depending on what items you want to drive, but that is how it works. Okay. I hope this has been useful. If anybody's got any questions, please email us or on our Facebook page, DCC Train Automation, and ask questions through Messenger there. We're more than happy to help. Hope this has been of interest. If anyone got any questions while we're on, if they have, please quickly ask. Otherwise, I think that's long enough for this video. And I hope it's been of some interest to you. So the DR5000. And so the only other thing we could show you, I guess, is how we can use the throttle to switch the lights on and off over here. So if I go to mode, turnouts, and we get an 8. Hold on, what have I done here? Oh, it's not plugged in. Hold on. There we go. Get it 8. There we go. So if I press address 8, you can see that light there. The green one's going on and off. Yeah. 7. The red one's going on and off. Turnout. And over, you can't see that, but on the other screen. So you can obviously drive everything from your system by a handset as well. Or if it's the Z21 app, you could do it there. you can drive the loco at the same time. But, yeah. Put that on the same loco. When I drive it on the handset, and there's cables on the screen. There we go. So if I drive the loco here, it also appears in the other place. Really nice function of the DR5000 is you can have different types of throttles, whether they're wireless throttles or loco net or even express net throttles, can all be driven at the same time. Anyway, that's enough for now. If anyone's got any questions, drop us a message on DCC Train Automation Facebook page or via email at info@DCC Train Automation. Thank you guys. Speak to you soon. Take care.